Hello and welcome to this Lactanet webinar. Josiane, could you confirm me that you hear me and see my presentation, please?
I do confirm. Welcome, everyone. Go ahead, Jean-Philippe.
Thank you. So my name is Jean-Philippe Laroche. I'm a dairy production expert at Lactanet, working mainly in nutrition and forage production. So today I wanted to talk to you guys about your forage analysis. There's a lot of things that we can learn from this document. However, it's not everyone who will look at their forage analysis, and today I'll try to identify with you guys some points that you could possibly improve on your dairy farm. Sorry, I accidentally closed my mic. So before we start, I would advise you to have on hand one or two forage analysis that that is used for your high producing dairy cows. You should also have two highlighters or pens of different colors, for example, yellow, green, black, or red. It's not mandatory, but it will help you to underline what's good and what's bad on your forage analysis. And of course, a calculator in order to do calculations. Sorry, the goal of this webinar is really to see what your forage analysis have to tell you, and most importantly, to provide you with solutions. So without further ado, let's begin. What informations can be drawn from a forage analysis? First of all, we can have a pretty good understanding of how of your harvest quality. We can know how mature was your forage. Did you harvest too late or too soon? What's the dry matter content? It's really important for your storage system. We can also know if you have too much soil contamination, which can seem dumb, but it will have a pretty strong impact on the quality of the forage and the quality of the fermentation too. We can also know the storage quality. So how did the fermentation go? Is your silage actually stable? Did you have excessive heating? And we can even know if your hay crop has mineral deficiencies. So for example, with the phosphorus and the potassium content, we can know if you lack of these elements. And we can also know if you have sulfur deficiencies in alfalfa. And I would say that at least in Quebec and probably too in Ontario in the Atlantic, I'm starting to see more and more deficiencies in sulfur for alfalfa. So that's definitely one thing to look at on your forage analysis. So is the quality of your harvest optimal? Here I show you on the screen a typical forage analysis that we will give to our dairy producers in Quebec. You don't have to have that exact type of forage analysis to work with us today. You just have to find the things that I will tell you in your specific forage analysis. And the first thing that we will look at is the acid detergent fiber content, the ADF. So in most of your forage analysis, you will have that number. For a high producing dairy cow, we want to aim at close to 30% of the dry matter. So it's important to look at the dry matter content here as a dry matter basis. So for example, if you have 29, 30, 31, I would underline this in green, for example, or put a black circle around it. But if you have, for example, 33%, 34, 35 or more, I would put that in yellow or red, because that's definitely something you can improve for your high producing dairy cows. And it's probably the first thing I look at in a forage analysis, because when you harvest your forage at the right maturity, everything will follow it. So you'll have better crude protein content, you'll have more sugar, more fat. So the overall quality of your forage will be better. So what's the difference on my farm if you have a better quality forage, so a forage that is harvested sooner? Oftentimes when I tell this to producers to harvest sooner their forages, they will say that they need fiber, right? So you need fiber in order for the rumen to be in good health. You need fiber to produce milk fat, which is in high demand right now. And that's true. But what we need to remember is that when we have a forage that has the right maturity, that has less fiber, we need to increase the amount of that forage in the ration or in the diet. And I wanted to show you an example of that right here. I see that there are questions. As you know, the webinar will be about 1 hour long. I'll answer the questions at the end of the webinar, because if I answer all of them during the webinar, we will be there like in 2 hours, still there in 2 hours. So, okay, so please keep your questions for the end of the webinar, or you can ask them in the Q&A section of the app. Thank you. So yeah, I wanted to show you an example between a good moderate mature forage and an optimal forage. So the average forage here has 33% ADF. That's what we see commonly in Quebec, at least. And we have an optimal forage here. And I went into our database and tried to put an average forage of that quality here and here, and I put two diets that contained the equal amounts of corn silage and forage, but I adjusted the amount of concentrates. And my concentrates were ground corn, soybean meal, and my minerals and vitamins. So in the first ration, or the first diet, I had a fiber content of 30.5. And in the second diet, I had the exact same fiber content. So I wanted my cows to ruminate at the same rate, if I could say. So here I just simply increased the amount of forage in order to achieve the same fiber content. So if we look at the forage dry matter content intake, we have 16.4 kilos here and 17.2 kilos here. So an increase of 0.8 kilograms of dry matter. When we look at the component corrected milk, it's the same in the two scenarios, and that number is calculated with the amount of energy that the diet provides and the amount of metabolizable protein that the diet provides. So how did I get the exact same number? It's simply because my forage here is of better quality, so it could have maintained the dairy production. If we have more forage, consequently, we will improve the milk to concentrate ratio. So the cow with a pound of concentrates will produce more milk because she has less concentrates in her diet to produce the same amount of milk, simply. When we look at the concentrate costs, there's an impressive decrease here. So we are at $14.97 per hectoliter here, and we are at 13.84 dollars per hectoliter here. When we look at forage costs, there's a small increase, of course, because we have more forage in the diet. But when we look at the feed cost, so the total feed cost, we have a decrease of 66 cents per hectoliter. You'll notice that those numbers are pretty interesting because you need to remember that's high producing group of cow. So you may not compare your specific values on your farm with these, but that example just show us that for a high producing group of cow, we can decrease by a lot our feeding costs. For those who want to know the prices that I used for my scenarios, they are here. So for ground corn, it's about $400 per ton. For soybean meal, it was about $750, and for minerals, it was about $1,500. So those are prices that we saw in Quebec in the past few months. So in that scenario, I simply replaced 0.8 kilograms of dry matter of concentrates by 0.8 kilograms of forages. I had no negative impact on milk revenue, but I have I had savings of 66 cents per hectoliter. And I shall remember you that this is just for a 3% differences in ADF. So ADF has a very important role to play in the feeding cost of our diets. So how do we achieve that amount of ADF? Well, in Quebec, we use a lot this technique that we call the fast and slow technique. It's a technique that will take advantage from the physiology of the forage plants. So as you all know, in the beginning of the season, we have high yield, but we also have a rapid quality decrease. However, in the end of the season, we have low yield and a slow quality decrease. So what that technique do is we simply harvest fast at the beginning of the season in order to have high yield of high quality. So for example, if you have legumes, you will harvest at the early bud stage. And if you have mostly grass in your mixture, you will harvest at late boot. At the end of the season, we just do the exact opposite. We eat later, because at this moment of the season, the quality will decrease really slowly, so we won't have much impact. But we will give time to those plants to accumulate reserves for the winter, so it will help them for the persistence. So for legumes, we will harvest at early flower, and for grasses, we will harvest at early heading. And between the two, you just do what you want. So if you want high quality forage and a lot of high quality forage, you could harvest fast. And if you don't need that much quality forage, you could harvest later in order to let your plants have more reserves for the winter. This strategy is very interesting because it will provide you a good yield, a good persistence, and also good quality. So you actually have the better of the three. Because if you were to harvest very fast at each cut, you would have high quality but low yield and low persistence. Whereas if you harvested late at all cuts, you would have high yields but low quality and a good persistence. It's also interesting because when you do that technique, the forage quality distribution will correspond fairly well to the different needs of the herds. So when, for example, we need high quality forage for our lactating dairy cows, but for dry cows and heifers, we don't need that much quality. So the next thing that we will look at is the dry matter content, and everyone will have this on their forage analysis. So you should never have a dry matter content less than 30%, because in those cases, it's a perfect recipe for a bad fermentation. And when you have over, which is good, you also need to adapt the dry matter of your forage to your storage type, because in some storage type, even if you have 35% dry matter, you'll still have problems. So again, if you have a dry matter that is less than 30%, you should underline that value with, for example, a yellow color or a red color. And if you have above that value, we'll look at your storage system. Just so you know, 7% of our samples in Quebec that I saw in our database are too wet. I'm talking here about silage samples. So 7% are below 30% of dry matter. So that's a common problem. And we also know that we cannot always control this as we are dependent on the weather. So what happens when you have a too wet forage? Well, you'll have silage effluent, which is rich in nutrients. So you basically lose nutrients through these silage effluents. And you'll also have an ideal growth environment for bad bacteria. So those bad bacteria loves wet condition, and if you provide them with it, it will be harder to fight them. However, if you have a too dry forage, you'll have other problems. So the main one is poor compaction, especially in bunkers and in drive over piles. And you'll also have, if you have bad compaction, that necessarily means that you'll also have oxygen presence into your silage mass. And when you have oxygen, well, you have a risk of heating caused by yeast, molds. And with molds, you'll probably have mycotoxins too. So it's really important to have a silage that just has the right dry matter content. So what's the right dry matter content? Well, it varies between the different storage systems. So for example, if you have a tower silo with top unloading, the ideal range would be between 30 and 55%, but it will highly depend on the height of your tower silo. So here I have that other table that will help you. And the more your silo is high and has a high diameter, the more you want a drier forage to avoid silage effluents. So for example, if you have a 70 per times 30 feet silo, you would need at least 43% dry matter in order to avoid silage effluents. Whereas if you have a smaller silo, you could probably do well with a 30% dry matter content. When you have a tower silo with bottom unloading, the aerobic dry matter range would be 40 to 60%. For bunkers, it would be 30 to 40%. Driver over pile would be a little more humid as you need more humidity to enhance compaction, so 30 to 35. Tube silo would be 35 to 40%. We can do a good ag bag with 30 to 45, but the real optimal range would be this one. And for large wrapped bales, 45 to 55% dry matter would really be the optimal. And I don't know for you guys, but in Quebec, there's a couple of people that talk to me about wet large wrapped bales. I don't know if it's a common practice in other provinces, but it's really a bad idea. And I just wanted to show you why. That's a very interesting study that was done in 1991. They harvested an alfalfa grass mixture at 39% dry matter, so below the 45% dry matter recommendation. And the exact same forage was put in two different formats. So one in round bales, so the gray bars, and one in chopped silage, so the black bars. Here you see the evolution of pH according to the number of days ensiled. And here you see also the total acids. And the blue lines represents the stability pH, which is the pH that we need to achieve if we want to control the bad bacteria. So when we look at this, we see that the chopped silage, after 3 days, will achieve the stability pH. So that means no more bad bacteria that could do bad work. Whereas with round bales, even after 3 days, we stick with the same pH. And even after 60 days, we don't achieve the stability pH. So that means the bad bacteria will continue to deteriorate the quality of our silage. So what's the explanation behind this? When we look at this graph, we simply see that the chopped silage has more acids in it. But why? It's the exact same forage. Well, the answer is quite simple. Chopped silage is chopped, and round bales, even if you have rotocot, it's not as chopped as a chopped silage. And that difference, what it do in the silage is that you have less sugars that is available for a good microorganism. So if you have less sugar, you also have less acid and a higher pH. So that's the explanation. Does that mean that round bales is not a good storage type? Absolutely not. It can be a very good for a storage type, but we need to do something else to prevent those kind of problems. So in that case, that silage is a really ideal environment for bad bacteria because you have high humidity and high pH. So what's the solution? The solution is simply to harvest drier forages, because what it will do is that the drier is your forage, the higher is your stability pH, because at higher dry matter, the bad bacteria will be less strong and they will be controlled by a higher pH that is easier to achieve. So it's really the solution in those cases. And that's why in wet round bales, we often see butyric acid. Moving on to the ash content, which is an indication of soil contamination. So for the ash, you probably all have this on your forage analysis. Again, we're looking at a dry matter basis number. If you don't have ash, it's simply the sum of all the minerals. So for ash, we aim 10% or less. And as I said earlier, it can really have an impact on your productivity, on your cow's productivity. Again, when I looked at our Quebec forage samples, 18% of our silage samples have too much ash. So there's definitely room for improvement here. And I'm pretty sure in other provinces, we also have room for improvement. So I just wanted to show you the sample analyzed for ash that we have. Here you have the ash content on the x-axis, and on the y-axis you have the number of samples. So the most samples would be in the 9 to 9.5 category, but we also have very high ash samples. For example, I even had one sample that had like 21% ash. So all this orange zone is a zone that I think we have a room for improvement. Normal silage sample will have probably between 8 and 9% of ash without soil contamination. So why do we want to minimize ash? Simply because there's no energy in ash. So if you have a high ash forage, you will fill the rumen of your animals with minerals or soil, and the cow cannot produce milk with it. So you simply replace forage with soil, which is not good for productivity. Soil is also a source of bad bacteria. So when you put soil in your forage, you will inoculate that forage with bad bacteria. So as you increase the ash content of a forage, we will see a decreased production and an increased risk of bad fermentation. Just wanted here to show you an example. If we have the same forage and we have 10% ash, with that specific forage, we will produce 1,200 kilograms of milk. If we have the same forage but with a higher ash content, we will greatly reduce the amount of milk. And I don't know those numbers will not tell you much, but if we put that with a cow that eats 16 kilograms of that forage, moving from 10 to 15% ash, you lose 2 kilograms of milk. So that's a lot. If you have 12.5% of ash and you reduce it to 10%, you'll gain a kilogram of milk. So that's really impactful. How do we lower the ash content? There are main solutions to that, but I would say in the vast majority of the cases that I saw, cutting height is the most efficient solution. So the cutting height needs to be 4 inches or 10 centimeters. And it's not only a matter of soil contamination. There are also other proven advantages of cutting higher our forages. It will increase persistence. It will lower the amounts of weeds. So as you know, when you cut a forage really low, the forage will have a hard time regrowing, whereas the weeds will be able to grow faster. So that's how we reduce the presence of weed by increasing our cutting height. We also lower the soil drying, as the stubble will protect the soil from the sun. You will see a real improvement in the regrowth, especially for grasses, and you could try it on your farm. So you could harvest the half of your field at 4 inches and half of your field, let's say, at 3 to 2 inches. And for grasses, you'll see a big difference. So it really it will improve the regrowth of your grasses. And finally, it will also improve drying speed, because air will be able to go beneath sorry, I lost the correct term. The air will be able to dry the forage beneath it, so it will really improve also the drying speed. Other possible solutions would be to have flat blades on your rotary mower. If you have angled blade, it will act like an helicopter, so you will have a suction effect, which will increase the soil contamination. Flail conditioners can also have a suction effect, and for silage, conditioners are not necessary. I will talk about this later, but it can also increase the soil contamination. Large swath is really important, and it can be counterintuitive because we know that when we have large swath, we can roll on the swath. But the studies that have studied this show that when you have large swath, you have less ash content. And the reason is that when you have a narrow swath, it will be heavier and it will press on the stubble and it will be closer to ground. And after, when you go with your harvest equipment, you'll harvest more close to the ground. So that's the reason. Of course, we need to adjust the tether in the brakes. So not only the height, but the speed also. Sun rakes, if studies have shown that sun rakes will increase soil contamination. So personally, I would try to avoid that type of equipment if possible. And finally, we need to adjust the speed of the harvest equipment as well. So now that we looked at forage quality at harvest, let's look at the storage. So did your storage negatively affect quality? First thing we will look at is the fermentation process, and we have 4 things to look. First one would be the lactic acid to total acid ratio. So if you don't have that ratio directly on your forage analysis, the calculation is pretty simple. So you just need to take lactic acid and divide it by the sum of lactic acid, acetic acid, and butyric acid. So you need at least 65% of your acids that are lactic acids, which is basically a sign of a good fermentation, and the stronger acids the acid that will decrease pH. Acetic acid, we can have some, it's not problematic, but if we have more than 3%, it can be an indicator of a bad fermentation process. If you have a heterofermentative inoculants or combo that contains Lactobacillus buchneri, it can happen that you have 4%. And it's normal in that case. But if you don't have that type of product, you should see 3 or below. And if you have over 4, it's really problematic. And it's really an indicator of a bad fermentation pattern. Butyric acid, so we should see less than 0.3%. Ideally, we want 0 of that acid, but it's not always possible. So the goal is really to aim below 0.3%. And by the way, on some forage analysis report, we don't have those numbers. So if you don't have those numbers, it can be normal, but I think it's important to ask for them because it can really help you guys to improve the fermentation of your silage if we understand how well the fermentation did. Sorry. And the last item to check is the ammonia concentration, so nitrogen NH3. So again, it's not always on your forage analysis, but if it is, it will be named like this or ammonia. And we want to look at this number on a crude protein basis. So that means if you have ammonia on a dry matter basis, you need to take that ammonia and divide it by the amount of dry matter. You need to take that amount of ammonia in a dry matter basis and divide it by the amount of crude protein. So for example, if you have 2% of ammonia as a dry matter basis and 20% protein, you would take 2 and divide it by 20, and you have 10% of your crude protein as ammonia. So here the magic number is 15%. If you are over that number, again, you can underline it on your forage report, and that is also an indicator of a bad fermentation. And what that tells us is that you had protein degradation on your forage sample that was done by bad bacteria such as Clostridia. Again, 17% of our samples in Quebec, silage sample will contain too much butyric acid. So it's a common problem. It's not, it can be solved, but it's a common problem. So what are the effects of bad fermentation or poor fermentation? In one word, it's expensive. So you'll have dry matter and nutrient loss. And when you lose nutrients, you will really lose the better ones. So like sugar, protein, for example. You'll also have a decrease in protein quality. So protein will be converted to ammonia. The cow can still work with ammonia, but you'll probably have to buy more bypass protein. And we all know that this bypass protein will cost a lot. We also know that bad bacteria will produce other things when they are in your silage, such as cadaverine. I lost the other components, but those are components that will smell really bad, and the cows will detect it, and it will really lower the palatability of that forage. You can also have even problems, health problems in your animals. We know, for example, that butyric acid can really cause ketosis problems if we feed too much. We also know that with bad fermentation, we can have mycotoxins, etc. So it's nice to know, but now I guess you all want to know what's the problem with my forage analysis. What can I do to improve the fermentation process of my forage? We'll try to find out. And here I know that there are three main causes of bad fermentation problems. For your specific situation, the things that I will show you may not completely answer your questions, but most of the situation will be explained by one of these three factors. First one is excessive contamination of silage by bad bacteria. So as I said earlier, if you have high ash content, it's a sign of soil contamination, and we know that bad bacteria are very present in the soil. So if you have an ash content of 12%, it's certainly a part of the problem. We also know that manure can also contaminate your forage. So in order to lower the contamination risk, we need to have at least or more than 28 days between the manure application and the harvest in order to let the rain lower the amount of bad bacteria on your silage leaves. Second problematic could be that the silage is too wet. If you have a silage that has less than 30% dry matter, don't look further. It's probably the main cause of your problem. In those silage, it's pretty impossible to not have butyric acid. It could be also that your dry matter is not adapted to your storage type. So too wet for storage type. For example, if you have a large wrapped bale at 35% dry matter, that's certainly the biggest cause of your problem. And the second cause is more complex. So if you have an ash content that is okay, if manure is not the problem, if dry matter is not the problem could be here. And it's that the pH was too high for too long. So in order to have a good fermentation, we need a very rapid pH drop to really control quickly the bad bacteria. And in order to have a rapid pH drop, we need high sugar content. How do we achieve this? Well, of course, we want to avoid rain on the forage. We also want large swath, and I will talk about it in the next few slides on how does this increase the sugar content of your forage. And when I talk about large swath, it's 80% or more of the cutting bar length. So for example, if your cutting bar has a length of 10 feet, your swath should be at least 8 feet. Quick closing of the silo is really important too. Adequate level of maturity. So if your forage is really mature at an ADF of 40%, for example, you'll have less sugar. So less sugar means less fuel for your good bacteria and a higher pH. Chop length is also important in order to provide all the bacteria in the silage with free sugars. And it's optional, but you could cut in the afternoon to improve the sugar content. So in Quebec, studies have shown that if you cut at 6 p.m., the sugar content will be higher than in forage that were cut in the morning. I know it's not always easy to do this on our farm, but it can be an option. Second thing that is important to lower quickly the pH is have a good silo seal, so we don't want oxygen into the silage mass. And lastly, homofermentative inoculant or combo could really be helpful for hay crop silage. So right now we have enough studies, independent studies, to say that this product has a really good return on investment, and we'll talk about it in the next few slides. So why does ensiling as quickly as possible is important? What you need to know is that when you harvest, you cut your forage, it will still be alive. So the plant will still consume sugar unless there's no more oxygen or unless the plant is dry enough. So the quickly you dry your plants or the quickly you put it in a silo, the less sugar it will consume. And that's why it's important to put it in the silo as quickly as possible. So how do we get a silage that dries fast? Well, there are 4 basics rules that we need to follow. First one is to have good weather. So I don't think you will learn anything from that point, but it's really important to remember. So we need sun and no rain. Second rule is having a cutting height of 10 centimeters or 4 inches in order to let the air go through or beneath the swath here. We need no conditioning when you do a silage. It's different for hay, but for a silage, water needs to move through the stems when it dries. And when it gets to the leaves will do photosynthesis with the sun, and it will expulse the water content of the forage. So for silage, we need a good water movement in the stems, and if we condition that forage, water movement will be lower. And that's really important in the first phase of drying, and I will also talk about it later on the presentation. So for silage, conditioning is not necessarily, and it will actually decrease the drying rate for your silage. And the most important part is having white swath. So as I said, 80% or more of the cultivar. And there's a reason. It's pretty simple. So as I said, the forage plant is not dead when you cut it. And if you provide that plant with oxygen, not oxygen, but light, it will do the photosynthesis reaction, which will take water and light to produce sugar, which is really good for us because the plant will be using water and transforming it into sugar. What happens if you don't have white swath? Well, the first part of your swath that has access to light will do that same reaction, so taking water and converting it to sugar. But the lower part of your forage that doesn't have access to light will do the exact opposite reaction. So it will take sugar and produce water and energy. Of course, that's not what we want. And some experts in the US will call this process compost drying because it's the exact same reaction that we see in compost. Of course, when you do narrow swath, you won't have compost, but you will have the first reaction that leads to compost, and you'll have less sugar in your forage. So it's really important to have that large swath. Mower conditioners, yes or no? So I regularly have this question. I wanted to answer it with you guys. So here you have the moisture curve over time. So as you can see, it will decrease really fast at the beginning, and it will be harder to lower at the end. So in the beginning phase of drying, you have photosynthetic drying. which is what I explained to you. So the water moves through the stems, goes to the leaves, and the leaf produces photosynthesis to produce sugar. But at the intermediate or final phase, the leaf is not able anymore to do photosynthesis, and the water cannot escape by the leaves, so it needs to go somewhere else. And that's why here we need conditioning. So the question you probably all want to ask me right now is, where's the limit here? Well, here we talk about haylage. So what can we conclude from that graph is that when you do large silage swath, you don't need conditioner. When you do large swath of haylage, it's a gray area. So personally, I would probably not buy conditioner for that, as you probably won't increase much your drying rate. But for hay, it's definitely important to have conditioners in order to faster the overall drying rate. So I hope it's clearer with that graph. Inoculants, do they work? So here I'm really talking about homofermentative inoculants, which contains bacteria such as Lactobacillus plantarum, Pediococcus, and Enterococcus. So the job of these bacteria is to quickly acidify the silage through lactic acid production, which is the main acid that we want. And like I said to you guys earlier, we have enough independent studies right now to say that those products are really interesting for hay crop silage, because they will reduce dry matter loss. And when you put a price on that dry matter loss, it overpays a lot the product cost. So for hay crop silage, it's really a no-brainer for me using homofermentative inoculants. And here I show you a study on pH, which, as you now know, is really important for the silage. That study showed that with alfalfa, other legumes, and grasses, we have a significant decrease of the pH when we use those kind of inoculants, which is really good. That's what we want. But in corn silage, we don't see improvement. And that's because corn silage will naturally ferment well. So homofermentative for corn silage, not really necessary. The answer could be different for other type of inoculants like heterofermentative, but for homofermentative, you don't need inoculants in corn or sorghum in that case. Well, now you have looked at your forage analysis. If you have butyric acid and more than 0.3, you need to see if the animal are fed too much of that butyric acid. So you need to know how much dry matter of that forage your cow will eat, and you need to multiply that number of dry matter by the percentage of butyric acid. So for example, in that case, we have 8 kilograms times 0.5%. So we need to divide by 100. So that means 0.04 kilograms, which means 40 grams of butyric acid per day per cow. And we know that for lactating cows, when we have over 50 grams per day, we're going to have problems, especially ketosis, loss of appetite, decrease in milk production. And for drying transition cows, we should have maximum 20 grams per cow per day. Ideally, we should aim for 0 because, as you know, ketosis could be really problematic for your transition cows. So if your calculation reveals that you feed too much butyric acid to your cows, we have basically 3 solutions. First one is to dilute the silage with another silage of better quality in order to lower the amount of butyric acid that the cow receives. The second solution is to allow the forage to air out 12 hours before feeding. So butyric acid is a really volatile acid, and when you air out the forage for 12 hours, it will reduce the amount of butyric acid by 50%. So it can be really helpful. And the last solution is to simply throw out the bad forage, which of course we don't want to get there, but when we have really bad silage, that's the only solution. Now let's move on to silage stability. So we want to look at the pH level. And like I said earlier, the pH level with optimal pH or the stability pH will depend on the dry matter content of your forage. So the drier your forage, the higher the pH to achieve, and the wetter your silage, the lower you have to achieve a certain pH. So here you have a graph with alfalfa silage, or it could be also legume silage, clover, for example. And here you have corn and grass silage. If you have forage mixture, I will advise you to look at the yellow line here. So you take the dry matter that you have. For example, here I would have a 40% dry matter mixed silage. In that case, I would need to achieve a pH of 5. If my pH is 5.5, the growth of bad bacteria would be possible, so my silage would not be stable. Whereas if I have a pH of 4.5 or 5, my silage would be stable and the bad bacteria would be controlled. So if your silage is not stable after 21 days of fermentation, you need to get rid of that silage as soon as possible, especially with high temperatures, as the bad bacteria will continue to produce butyric acid and degrade proteins. Heating. For heating, we look at what we call CP-ADF, which is not always on your forage analysis report. It could also be named ADF-N, so for ADF nitrogen. It could also be named ADI-CP. So those are the three major names that you could see on your report. Again, we need it reported on a crude protein basis. So if you have, let's say, 2% of CP-ADF and 20% of crude protein, and the 2% of CP-ADF is on dry matter basis, you need to divide 2 with 20, which means 10%. Again, the magic number here is 10%. So if you have more than 10% of your protein that's as CP-ADF, you had heating problem on that silage sample. And you need to know that CP-ADF is protein that is completely unavailable to your animals. So even in the rumen or after, the cow won't be able to take that protein. So it's really protein put in the garbage. Okay, so again, if you have more than 10% here, you can underline that value of a specific color. In Quebec, 11% of our samples would have heating problems. So again, that's an area that we can work on. And we probably have other heating problems too in other provinces of Canada. So what happens when we have heating problems? What's the cause of this? Well, it's really simple. So as you will ensile your forage, you will ensile a natural population of yeasts. During the normal fermentation process, those yeasts will multiply until there's no more oxygen. So they absolutely need oxygen in order to grow. Now, if you reintroduce oxygen into the mass of silage, that's where you're going to have problems. First, the yeast multiplication will continue at an exponential rate. The yeast will consume lactic acid, so it's really a bad news for us. With all that biological activity, heat is going to be produced, and with heat, other organic acid will volatilize, so the pH will go up. And when the pH goes up, you have other bad microorganisms that will take the place, like molds, like other Clostridia. And at that stage, you have lost control. So it's what we call aerobic instability. So in order to prevent this, you need to limit the amount of oxygen present into the silage. And there's a couple of solutions to avoid that. So what needs to be checked if your silage is heating up? First of all, especially for bunkers, for drive-over piles, for ag bags, compaction is the key. So if you have bad compaction, you have a lot of air into your silage. If you have a silage that has been exposed to oxygen for too long before silo closing, it could be also an explanation. Silo seal that is not optimal would also be an obvious things to look at. Silo phase that is not uniform. So in that case, you could see that oxygen, it's really hard for oxygen to go into that silage mass, whereas in that case, the silage here is probably full of oxygen, so it's probably already heating. And there's a lot of doors here for oxygen to enter into your silage mass. Removal rate would be really important too. So in summer, you need at least 6 inches per day for bunkers and drive-over piles. In summer it would be a feet, so 12 inches, and in winter it would be 6 inches. Whereas in ag bags, we need to double that number. Silage transfer can also be the cause of the problem. So some people would do corn silage, for example, in ag bags and transfer that silage after into a silage tower. So that can be problematic. Not always, but it can be. So if you have heating problems and you cannot really solve the problem, for example, you cannot increase your removal rate, you could use a product to help you. And there are two main products type that will help you, like Lactobacillus butyric and propionic acid, which is more expensive, but it's also more efficient. Lactobacillus butyric can also be really efficient, but it takes more time too. Finally, are your plants showing signs of mineral deficiencies? Here we want to look at phosphorus, potassium, and sulfur. Ideally, we want those numbers in wet chemistry because it will be more, the accuracy will be improved, but we can also look at it in infrared. Okay, so if you have less than 0.18% of dry matter of phosphorus, you have a deficiency. If you have less than 1.4 potassium, you have also a deficiency. And it doesn't mean that if you have, let's say, 0.25 of phosphorus, that you don't have a deficiency. But if you have a lower value than here, you probably have a problem. For sulfur, we only look at this for alfalfa, as it's a plant that needs a lot of sulfur to grow and to make her protein. We need at least 0.25. So I would only look at this in really a forage mixture that has at least 70% of alfalfa or a pure alfalfa stand. If you want to look at precisely the signs of deficiencies according to the species that you use in your forage stand, you can look at this table. Just so you know, you'll have a quick tips document that will be shared with you after the webinar. So that the table here will be also present in that file. But for example, in alfalfa, we need at least 0.25 of phosphorus and at least 1.6% of potassium in order to have good yields. If you don't achieve those numbers, the yields will be below 80 to 90% of the potential. If you suspect a deficiency based on your forage analysis, I would advise you to consult your fertilization advisor to really see if you have a deficiency and to see what would be the cheapest way to improve those minerals in your forage. For alfalfa, sulfur deficiency, as I said, can really be problematic. So I think I said it earlier, but historically we received sulfur with acid rain. Right now we don't have that kind of pollution anymore. So it's a good news because we don't receive sulfur because we corrected a pollution problem. But the bad news is that we don't receive that free sulfur anymore. And now we regularly see deficiency of sulfur in alfalfa, at least in Quebec. I know that in Ontario too, they saw it. Probably in Atlantic or in the other province too. And when you have alfalfa deficiency in sulfur, you see that the plants are yellower, and you also see that there's less yield. So if you have a deficient alfalfa and you put sulfur fertilization, you'll increase your yield by 1 to 4 tons of dry matter per hectare, which is huge. And you'll also increase your crude protein content by 3 or 4 percentage units, which is also huge. So that's really an important thing to look at on your forage analysis, is if you work a lot with alfalfa stands. I receive a lot of the question about grasses fertilization with sulfur. I don't have enough data in Quebec to say that it's an economically interesting practice. I don't know for the other provinces too. So for now, I would say that for alfalfa, it's really interesting, but for grasses, I don't have the answer. Again, if you suspect a deficiency here, you should consult your fertilization advisor. So what's the bottom line? When we do all, when we respect all the characteristics that I showed you, what type of, what's the quality of the forage that we will get? To answer this question, I went into our database and I put 3 categories of forages that respected those constraints. So I have grass forages, legume forages, and equally mixture. So when we look at the crude protein content, with grasses, we are close to 18%, which is really good for grasses. And with alfalfa, we are between 20 and 21. For ADF, of course, we are at 30% because that's one of the objectives. When we look at the NDF, neutral detergent fiber, we see that grasses have more NDF than legumes. But we also see that grasses NDF is more digestible. We also see that grasses have more sugar than legumes. And consequently, we see that the amount of energy is pretty much the same between the different type of forages. So the legumes will provide you with more protein, whereas the grasses will provide you with more sugars and more digestible fibers. But at the end of the day, when we look at the energy those forages give, it's pretty much the same when we harvest at 30% ADF. So we're already at the end of the presentation. In conclusion, when you use your forage analysis, I showed you that you can look at harvest quality, storage quality, and signs of deficiency. Most of all, you can identify solutions. So I think that looking at your forage analysis should be the first thing you do when you receive it, and trying to know how can you improve. Like I said, a quick tips document will be given to you after this webinar, so you can do the same thing with your forage analysis. So it's basically a document that resumes the critical points that I told you today. And really important, if you have specific questions or other questions regarding your forage analysis, don't hesitate to reach out to your advisor, so they will be able to help you in your specific situation.